All right, so now that we have those two numbers, again, they are not critical numbers. They're just where the derivative is, the second derivative is equal to 0. We draw our derivative number line. And when we draw that derivative number line, we are plugging into the second derivative. So specifically, I'm going to plug in the 1 and the negative 1/2. So I have my negative 1/2 and I have my 1. And just like before, we go right as we were setting the derivative equal to 0 and plug into that function. So you're going to plug into the second derivative, and you can plug into the second derivative of the negative 24 v squared plus 12v plus 12, or you can plug in to the factored form. So either of those are fine. It does not matter which one you plug into. Now, I'm going to go through it with the factored form because I feel like we haven't done too much of that in the videos up to now. So if I work with the factored form, and again, I could plug into the not factored form and that would be fine. But the idea is that this would create 3 columns for you. So in the first column, again, I have my number line over here. In the first column, or the first test point, I would test something from negative infinity to negative 1/2. So I might decide to plug in negative 2. So that gives us negative 12 times negative 2 minus 1, 2 times negative 2 plus 1. So that's going to be a negative from the negative 2 minus 1. And then here I have 2 times negative 2, so negative 4 plus 1 to get a negative. And then these two negatives become negative, and then negative times negative gives us, no, these two negatives become positive, and then positive times negative gives us a negative. The only thing that I wanted to point out here is just the need to use that first factor. Do not just, I know we ignore it when we solve for the variable, but it does matter in terms of the sign for what you'll get with the second derivative. And then you'll do the same thing for the middle interval, plugging in maybe 0. And that will give you a negative times a positive. So overall, you get a positive. So again, you can either go through the factored form or you can go through the standard form. It really does not matter. But the key thing is on your test, you need to show that you plugged in, you need to show this derivative number line. So what I found here is I found for the middle interval that I have a positive, and then on the last interval, I would find that I have a negative. Now, what do those positive and negatives mean? The negative, because we're looking at the second derivative, that is not telling us decreasing. Because it's the second derivative, this negative now means, it carries on a different meaning, it's now that the function is concave down on that interval. And the same thing over here, this negative means that it's concave down on that interval. And then the positive, that again carries on a different meaning when we're looking at a positive second derivative. It is now that the function is concave up. So our final answers here would look like as follows. We would say that this function is concave down on negative infinity to negative 1/2 union 1 to infinity. It is concave up on negative 1/2 to 1. Now, you'll notice that we have inflection points, and the reason why we have inflection points is because we do in fact change signs in concavity. So there would be an inflection point at negative 1/2, and there would also be an inflection point at 1. And that's because at -1/2, we change concavity, and at 1, we also change concavity. Now,